Our next concept is temperature independent terms. So whenever we use mass, that is temperature independent terms. What is the first one in case of temperature independent one? The percentage of weight by weight. Percentage of weight by weight. Mole fraction, molality, ppm W by W. Let's see one by one. Percentage of weight by weight, that is equal to weight of solute. Same thing. Here also we will do the comparison in between solute and solution only. Weight of solute, that is in grams, by weight of solution. Solute and solution only, comparison between. But here weight of solute by weight of solution, not volume. This also in grams, as we are doing percentage, in terms of percentage into 100. And here, as I told you earlier, in general, we'll take the volume of solution is equal to 100 ml. So just like that, weight of solution 100 grams. Volume of solution also, we'll take this one as 100 ml. These two are fixed values. So how much weight of solute dissolved in some weight of solution, in such weight of solution, that is percentage weight by weight. Next one is mole fraction. Next temperature independent term is mole fraction. We'll denote this one with capital X. If suppose we are taking A and B, substance A and substance B in a beaker, and we are adding those two things. So in a beaker A, this is B. So number of moles in beaker A is, we'll take this one as number of moles. Na, we'll take this one as number of moles Na here, and Nb, number of moles in substance B. Number of moles present in substance B is Nb. Number of moles present in substance A is Na. So if you want to calculate the total number of moles, when we mix these two things, Na plus Nb. This is also one equation. After adding those two substances, we'll get total number of moles. That is number of moles of A plus number of moles of substance B. Let's consider mole fraction one by one. Mole fraction of solute A, substance A. So what is the mole fraction? XA. We will denote this one with X, and we are considering for A, so that is XA. XA equal to moles of solute by total moles. By total moles. This is the formula for X, mole fraction. As the number of moles of solute is equal to Na by what is the total number of moles? Na plus Nb. This is when we consider XA. Next, let's see mole fraction of B. Or else we can say this one as solvent. Then XB, mole fraction of B, solvent, that is equal to moles of solvent by total number of moles. So what is the number of moles of B? Nb by total moles Na plus Nb. If we add these two things, means mole fraction of solute A and mole fraction of solvent B. If you add those two things, what we'll get? XA plus XB, that is equal to, what is XA? NA by NA plus AB, NA plus NB, plus what is XB? NB by NA plus NB. To add these ones, Na plus Nb, LCM, then Na plus Nb. So this is 1. So Xa plus Xb is equal to 1. This is also very important. Mole fraction of solute plus mole fraction of solvent is equal to 1. If at all any one either solute mole fraction or solvent mole fraction is given, and they may ask you another one's mole fraction. So how we can calculate that one? Xa equal to minus Xb, or else Xb equal to minus Xa. If one value is known, we can calculate the other value also. So this is also very important expression. We'll use this one in upcoming topic, that is Raul's law. Raul's used same concept and described his own law, that is Raul's law. This is about mole fraction. Then the third concentration term is molality. Temperature dependent term is molarity. Temperature independent term is molality. Molarity is denoted by capital M, whereas molality is denoted by small m. Small m. Excuse me. With small m, we will denote this molality. So what is molality? Moles of solute present in per kg weight of solvent. Listen carefully. Moles of solute present in weight of, anyway we'll take weight only here. In case of temperature independent terms, not volume only, no. So weight of, not solution here, solvent, and that too in kgs. Moles of solute by weight of solvent. This is the exceptional case. In this case, we are comparing the solute with the solvent, but not with solution. Up to now, we calculated or we compared the solute values, either mass, volume, or equivalent, or mole fraction, whatever it may be. We compared all those terms with solution. But in case of molality, we'll compare the solute with solvent. This is the exceptional case. So molality is equal to, small m is equal to, moles of solute. We'll represent this one with N by weight in terms of kgs. And that too, this one's weight is solvent's weight, but not solution's weight. So we know the moles of solute. How we'll get the value of N? W by molar weight. M naught. Molar mass. We consider mass, molar mass, or weight by molar weight. So substitute this one in the expression. So small m is equal to, and what is the value of N? W by M naught. W by M naught into W in kgs. Or this is in kgs. If we convert this one in grams, or else gram weight is given in grams, then W by M naught weight in grams, conversion is 1000 by 1000. So it will go up, and W into weight of solute into 1000 by molar weight into weight in grams. Weight of solvent in grams or kgs. Simply, no, if given in kgs, simply we can divide. No need to multiply with 1,000. So this is about molality.